Hello and welcome to another tutorial. So what we're going to be doing this time is we are going to be continuing to add to the first person controller. It has grown quite a bit over time. So the big addition I'm going to be doing this time is adding in support for different movement modes. So there's going to be a lot of refactoring for the controller and some pretty major refactoring. And so I'm going to talk through a little bit the process of how sort of going about that and the thought process there behind it, because that is something that's going to be necessary at times with the code that we work on. That we'll implement a version and then we realize, okay, there are larger things that I want to support. And we kind of have two ways to go, where we can either sort of jam everything into the existing code and it can kind of really balloon out in size and become quite hacky, or we can do some refactoring at that point to actually make it that it is more modular, it's going to be easier to extend. So generally, if time permits, I would recommend doing the refactoring approach. It's going to be something that's a bit more robust and more maintainable long term. So we're going to do that refactoring, and then what that's going to allow us to do is very easily add in support for a flying movement mode. So getting these different movement modes set up will allow us to then do things like later on have stuff like swimming, have stuff where they could be climbing on ladders, so different ways for the character to move and being able to swap those in and out while it's actually running. So our first step is we need to do a lot of refactoring. And the big thing going to do initially is actually get set up a bit of a description of what these movement modes are going to be and setting up our different scripts for it. So we currently already have our main sort of scripts folder here. And what I'm going to do is I'm going to, under this, create a folder for movement modes. And then I'm going to create a couple of things here. So the first thing I'm going to create is movement mode. So this is going to encompass moving along the ground. So that means everything related to moving along the ground. So not just taking steps, but also running, jumping, and also crouching, because those are all related to moving along the ground, because something like crouching doesn't really make sense when we're flying. Same like jumping doesn't make sense when we're flying. So we're going to have it that we've got movement mode for on the ground. And although it won't do anything yet, I'm going to set up a movement mode for flying. And the goal with doing this refactoring, we do the refactoring well, then it's going to be something that actually is really quick and easy to add in. That's going to be sort of the goal there with this. And the final thing I'm going to set up is, because these movement modes have to correspond to a very specific pattern for us to use them. And the movement modes themselves probably shouldn't store much in the way of data, or at least the data they store is going to be very different. The data needed for flying is very different to the data needed for walking along the ground. So I'm going to actually set up an interface in this case. So the reason for using an interface versus using a abstract class, for example, is that I don't think there's going to be a lot of data that is in common. And, an interface, these days we actually can set up data on it, but I don't think there's going to be a lot of stuff in common, and I don't think there's going to be, a need there for sort of the things that we'd often get with an abstract class, where there's a lot of logic as well that's common, because there just won't be very minimal. So an interface, I feel, is a better option here. So let's start configuring these. So the movement mode, I'm just going to mark that as an interface for now, and just clear out the contents of this. So this will be something that, how I'm going to approach this is I will add to this as I'm actually going through and doing the refactoring. So the challenging thing with refactoring code is you do break a lot of stuff in the process. So I'm going to make sure this inherits from or implements eye movement mode. So yeah, when we're refactoring, we break a lot of stuff. That's just kind of how it tends to go. It's kind of how it has to go when we're doing a lot of refactoring. So, okay, where we want to start with is probably the area where most stuff is going to come through. So I think that's going to be our fixed update. So there's going to be a bunch of things here. So we can already see, well, adding gravity, that's something that won't necessarily be applicable. It's applicable for the ground, but it might not be applicable for other things. So, okay, I want to be able to have something where that's being handled by this new system. So I want to actually set up for the new system first. So I'm going to create, same place here where I was creating the rigid bodies and everything. I'm going to have eye movement mode, and we're going to just call this movement mode. And that'll be something where I will actually, for now, mark that as a serialized field. Later on, in a future update, that's something where we would be dynamically changing that. But for now, this is something that I'm happy to just have as being a thing we specifically configure and set on it. So, okay, movement mode needs to handle a lot of these different things. So first thing I'm going to add in is, okay, I think movement mode, I want to have stuff where it's handling a bunch of things from fixed update. Now, I don't necessarily want it to handle everything from fixed update. There are things here that would be useful for potentially being able to just have stay remaining in this. And what I want the character motor to be doing is controlling kind of the sequencing that different things happen. So I'm going to have a few functions, I think, for fixed update. So this first one is kind of doing a bunch of sort of initial things, really, is what it's doing. It's doing some initial checking, and it's getting essentially things figured out for it of what are some basic common things that we need to apply. So I think that's a good way of sort of applying this of, okay, well, this can be fixed update, and this can be our initial thing. We do have this grounded check, and I think the grounded check should apply for any of the movement modes just because there's a bunch of things related to it. So I'm going to call this, fixed update, and we could call this pre-grounded check. Or different phases. So the naming of these things, we want to give a sense that this is the first bit of stuff happening in fixed update. So I'm going to call this pre-grounded check. So okay, that's one of the first things that's going to happen. So I'm going to add this into our interface. Then in the ground. Now, start and update for now, I'm just going to get rid of those, but we'll have our function. So that's good. And what I would then do is move the things that can over to that. So gravity is one. That's able to go over here. I would also move the alignment. So good so far. Now that is going to mean there's a few different things we'll run into that'll provoke errors. That's okay. We're intentionally not going to try and fix them just yet. So the grounded check, that's actually something I think that should go over to the movement mode. So we're going to say movement mode, and we can tell it to go, okay, fixed update, grounded check. Because that's something where for a lot of the different movement modes, there is potentially something it could need to be doing there. So I think that's a valid one to have for all of them, because when we are, say, flying, us being on the ground could have meaning. So when we're swimming, us being on the floor could also have meaning. So I think it's good to have this be something that's common like that. So raycast hit. Then similar thing here. That's going to be like that. Now, in terms of what this does, it's actually entirely that update is grounded function. So what I'm going to do is I'm actually going to move over the entire update is grounded function. So we'll take the function in its entirety, and we do also have these other ones like update movement. So I'm going to take both of those because both of those would make sense for us bringing over. So we'll bring both of those ones over. Which that does, we can see there's a bunch of other ones, and like I said, this is going to create lots of errors to begin with, and that's okay. We want to have those errors happen, and then we're going to fix them. So stuff like the footstep audio, check for step up, updating jumping. We can see all of these different ones. Running also needs to move. We know crouch has to move as well. So all of those are going to head over as well. Surface effects won't, because that's something that could make sense for other ones as well. So, okay, brought that over. Now, our grounded check here, we're going to have this is our grounded check result, or our ground check result. We have that, and we will return that. So that's good. So our character motor has shrunk by quite a few hundred lines of code, which is good. We wanted it to be reduced in size, and that's sort of one of the benefits of doing this is all of our files end up being a lot smaller. Now, okay, well, the coyote time stuff and running, those are all only applicable to the other one. So to our grounded movement, same for updating if we're running. So I'm going to take those, and those can come over into here. So we just be very slow, methodical with the changes that we're needing to make. We can see we do need to know if we were previously grounded. So even though this code is going to not currently work, I am going to, we just need to watch with this for autocomplete, can really mess us up. So that's good. Same with the was running, so I'm going to store that here as well. And I just want to get the bulk of things moved before I start trying to fix the problems. And that is an important thing. We want to resist trying to fix the problems too early, because if we try and fix them too early, that's actually going to get us sort of off track, and we'll end up fixing things that we don't really need to be fixing. So we do want to be a little bit cautious with this. Now this only happens if it's now back to being grounded. So we could actually do some specific checks here and only run this logic if it has gone back to being grounded. Because what I could do with like of this is, okay, well, that would make sense for it being able to go over into here, or depending upon where we how we sort of wanted to structure this, I could also do this where what I do is I then at this point go, okay, well, movement mode, fixed update, and rather than being grounded check or anything like of that, I could go on became grounded. So that works. That way then this stuff is a little bit more constrained, and we have something that could work for flying, for example. So everything can then get that message. So we add in this as well with a void fixed update. On became grounded. Then we'll have similar setup over in here where we will have public void fixed update, and again we need to watch for autocomplete messing us up. So we've added that in, so that's good. So we've now got quite a bit of stuff moved out of this. Now, there's a bunch of stuff that we were doing with the surface effects, because we saw that where we were doing stuff for sort of clearing surface effects, things like that, depending upon whether it was grounded or not. So we've got this updating here that happens. So that's something where the surface effects side of things, I'm going to actually change this to, okay, well, F is grounded. And then I can actually simplify this a little bit more, saying, have we returned to the ground? So that simplifies this logic a little bit, because we now know, it's a little bit of a cleaner check. We don't access was running anymore, so that's simplified a little bit further again. And surface effects, we kind of want to keep those in the character motor side of things, because surface effects kind of apply to everything. And so in our movement ground, where we've got surface effect stuff, so like of this, when it's detected that it's hit the ground, this actually belongs over here. We should make sure that we only do surface effect stuff when we're actually on the ground. So it just keeps it a little bit cleaner. And we can also then, because if we know we're not grounded, we can set the surface effect source to null. So that's good. We've got a couple of bits cleaned up there. So our fixed update now, we run our pre-grounded check. We do keep track of if it was grounded. And if we are, we update surface effects. We check if things have changed there. We have our logic for running if it has returned back to being on the ground, which is good. And then we need to have it do our actual movement. So this is something where I would again go movement mode, fixed update, tick movement. Because we've gone and updated everything else. So the movement generally being the last thing actually kind of makes sense, because movement should happen after we've organized all of the other bits. So now we then have our other interface for this, where again it has that hit result because there is information it often needs. So this is our ground check result. And then we can add this function in. So we've added in a lot of errors, and that's okay. We want there to, at the moment, be lots of errors. We want to get to the point where it feels like we've transferred the majority of things. So again, coyote time stuff moves over. I intentionally haven't moved any variables yet. I want to hold off on moving stuff with variables until I feel like I've got the bulk of the actual bits of code moved. And we can see character motor doesn't have too much in the way of errors, which is good. Late update, well, that's one where, okay, movement mode, we're going to add in a late update tick that will do the update crouch in. So again, I movement mode, late update, tick, And we will set that up here as well. So public void, this should actually be public as well. Late update, tick. Now, the movement mode is going to have lots and lots and lots of errors in it, and that's okay. At the moment, the character motor has none. We just want to check in terms of other things that we might need to move, and there almost certainly will be. There will be variables we'll need to move, but we'll get a sense of those once we start looking at implementing the movement mode, fixing its errors. So far, looks all good. Healing, damage, stamina, health, I want to keep where they are. Movement locking, things like that, those all look fine. So our character motor is a lot smaller now. And our movement mode, everything related to movement is now also just contained in one file. So it doesn't have stuff related to health, things like that. So that's good. So now we need to start looking at how do we actually have these sort of working together, because there is shared information that they need. And so we need to make sure that's a little bit easier for it working with. So there's going to be some things where the data is shared, where there's things like R is grounded, is running, stuff like that is common. So we've got some common state information that we likely need to have accessible to the movement mode and to the character motor itself. So what I would do in a case like this is I would actually set up essentially a class for this. So I'd have something like public class motor state, and we'll actually just create that at this point. So this is protected motor state, and I'm just going to call that state. So the idea is that state variable is what we will link to for everything. So our movement modes, we're going to give those a function, we'll call this initialize, where what it gets given, well, it's going to want the motor config. So we're going to include the config in here. And it's going to possibly need the character motor itself. So I'm going to actually pass that in. And we need the motor state. So that we can access as character motor state. So we just want this. This will give it all of the setup. And the reason for putting this in a class is by having it being in a class, that means when I give that to the movement mode doesn't get a copy of it. It links back to the one which character motor owns. So it means that it's essentially a shared bit of data, which is exactly what we need for this. So that means our initialize, well, then what we can have is character motor. We'll have our character motor config. And we will also have character motor and the motor state, like that. Just make them so that they're sort of in order. So then we store these. So config is equal to config. So we've linked those across now. So the idea is this gives us a bit of, and I'll make these protected actually. These gives us a bit of shared state that we can be putting things into. And we just need to make sure to make that public. So where I would initialize this is down here. And I would do this in start because it is talking to another object. I think start is the most appropriate place for it to happen. So movement mode, initialize, and we give it the config, ourselves, and the state. And while we're here, we can see these things for the link collider and those actually make sense to go in the movement mode. So we would set those up here. So, okay, we're at the point now where we've got a lot of errors that we need to fix. So how we could go about approaching this? What I would start doing is I would start looking at, okay, what are these bits of information here? And are those bits of information things that should be common? So they should go into the state, or are they something that is very specific to the movement mode? So the collider is common. Rigid body makes sense to also be common. Drag, that's actually specific to the movement for the ground and stuff that it's doing. So I would make drag something that exists here. So, okay, we want collider and rigid body to go into our state variable. So this is where I would start doing things that are going to break the character motor. So all of these ones for linked rigid body, those go into the state, and we change protected to public. So that's going to break a couple of things where we're working with stuff like these, but that's okay because we change these to be state dot, and then they're happy. Now, if we then go over to the movement mode, we can do a similar thing of state dot, and that will work. So we're starting to address some of the errors, which we do have 159 of them. But that's okay, because a lot of these are going to be fixed in pretty much the exact same way, where we do state dot. Now, is grounded and is running, those are absolutely things that we use a lot that should be common to both of the stuff. So I'm going to take is grounded and is running, and I'm going to put those into here as well. Public pool is grounded, public pool is running. And while I could set up helpers that directly refer to it, I'm going to actually just go with having those access from the state. Same with these. We could set up local gravity things inside the state, and I still might. But for now, we can just go with fixing those. So we just access state for each of these. So now when we're going through, we do want to adopt an approach of, as we encounter errors, in particular if we add in new ones, just generally going and fixing them. So that's good. Now we can start to update these ones. So it ends up being lots and lots of different ones. We've got things we're working with colliders. We'd expect those to generate lots of errors. So we're just looking through for anything where it's accessing grounded or the rigid body. And we're going and updating those, which is going to be a lot of the things in it. There are going to be many, many, many things where we're updating that. Now, the update is grounded. That set surface effect source, we've already got that covered in the main code, so we can get rid of that bit here. We have a lot of input stuff we're going to need to handle, which is okay. And we're already down to under 140 errors, so that's progress. And this is the thing, this is why I did the functions first and not the variables, is because the variables, there's a bit more of a decision we need to make. The functions are quite clear-cut of what stuff we shift where, but the variables do require a bit more sort of thinking about how we actually want to handle it. So any of the bits with the collider are straightforward for updating. And then with each set of variables, we do want to assess what stuff we should bring over. And there'll be a lot of ones where we'll make a change and it will actually get rid of a huge, huge swath of the errors, which is good. That's sort of what we want, is to be able to be cleaning up a lot of the errors. Crouch is another one that will probably end up being something that goes into the common state because it would make sense for it to be. So, okay, we're not at under 100 errors yet, but we're making progress. Drag, well, that was one we did identify should move over. So drag, and we can see these things like the jump time remaining, all of those make sense to move over. So I'm going to grab those and bring those over to the, not the player character motor, player and AI ones will probably be a little bit unhappy with us for a bit, but that's okay. Those will be easy to fix. So the thing, we transferred a few variables. That got rid of 13 errors. Cam recurrent time, I'm going to, from memory, only the player character motor uses that. Yes, so that's one that I'm actually going to just move over to the player character motor. So we've moved that. So, okay, now we've got to some more fun ones. We've got things like current height, which we use a lot. So current height and current max speed are both ones that it actually makes sense for those to have to be there for every single movement mode. So I've cut those and I'm going to paste them in here for now. That will introduce some other errors. But what I'm also going to do, because I want to mandate that those have to be implemented. So I'm going to actually set up public float current height, get, and set. And do a similar thing for, make sure I get the exact spelling right, current max speed. So we have that. And now I don't believe we can omit the set in a case like of this. That's something where, and also that doesn't actually need to be public. It's automatically being an interface is public. So we've got that property set up. That'll actually mandate that we have to have the property here. And what you'll notice is it's going to force us to have to put in a set, which is okay, because what I will do is I will throw a new system.notImplemented exception. And what we will say is height, current height, cannot be set directly. Update the motor config to change height. So we don't permit it happening, but we give a helpful error message for indicating what the problem is. So we do the same here. So current max speed to change speed. So that's good. So now things like our current height and stuff like that work. We're also then possibly, we may have introduced errors into the character motor side. We haven't, which is good, but was good to check just to make certain. So we've got other things where it's still going to have issues. So coyote time, we can start to take pretty much everything here. We've got jumping, we've got coyote time. Those are all things that are very specifically just used by the movement generally. So these are things I would just move directly over. We'll use this as an opportunity to format these a little bit. We'll bring over crouch stuff as well. I will leave actually the crouch just for a little bit, because I think with the crouch there is going to be a couple of things there that we might do a little bit differently, and that is crouched I think makes sense to go into the state. So we'll have public bool is crouched. So crouch can go into the state, but everything related to the rest of the things for crouch I think can actually go into our, just directly here in our setup. So, okay, now we can start to go, state is crouched, So we're already down to under 100 errors. So we're continuing to get rid of these, which is great. And crouching will get rid of probably quite a few of the errors, so fixing that up. The current parent would make sense to go in the state as well. So current parent is another one we're going to update. These are a lot of vector ones. Now currently can jump. The character motor actually controls that. We can see that's tying into stamina. So that's something where what I would do is I would actually change that to motor can currently jump. So that's good. Surface, so we do have to resolve a lot of the surface stuff, can currently run. Again, motor dot. Input we know we're going to have to address. Now the state we don't have is jumping in there. And if we take a look where we set up is jumping, so that is actually tying into a couple of different things. So we might actually, with the jumping, that may be something that we don't need to have go into the state. We'll take a look and see once we've updated all of the crouch things. So we might change that. So that's looking a lot better. So far so good. We've got a lot of things for our up vector and stuff like that. So we do refer to the up vector and down vector quite a bit. And that was something where in the character motor, one of the things was considering was I could move these into the state. So I'm actually going to do that. I'm going to take these and put them into here. That way everything else can just go and do, state dot up vector or state dot down vector. So it will break things in here. We have lost the current stamina, which stamina and health were a little bit too gung-ho with stuff we transferred over. So we'll bring those back. And we're down to 51 errors now. So we've gotten rid of a lot of errors. We'll have a bunch of things for the up vector. So again, we resolve these physics ones. That's going to sort out quite a few things, which is good. Current parent, I'm going to just directly move that over into the state as well. That is something where we absolutely it makes sense for that to be stored in the object here, because the transform parent absolutely is something that is common state information that it makes sense for multiple things to be aware of. And that will clean up more errors. So we're barreling through these, and it's this is a bit of a mindless process, but it's just about being very methodical with what we do. That we go through, we make sure we update each thing carefully, and as said, I would always recommend doing functions first, then variables. That's going to let you work out what stuff you need to change based upon how it's being used. So I think that's a way that seems to be a little bit more reliable for refactoring the bits of code. So, okay, that's pretty good. Now I've got all the input, and that's something where the input stuff, that actually belongs in the state as well. So I'm going to take these bits of input and I'm going to move them into the state, because absolutely makes sense for them to be here. And I will change the naming. So I'm going to get rid of the underscores, because that's going to help provoke errors, which I kind of need, so I can capture all of the particular things that need to be fixed up. And then we'll have a lot of things in here that change. So anything where it was working with any of the input ones, we can now change that to state. So we have our input coming through. Now, what we do with the input here that's something where probably we don't want to go and necessarily modify that input for everything. So I would actually set up vector2 movement input, and if, and I might actually just make it that it goes directly to state input move, and then these change to using that, just so that we're not going and sort of stomping on the particular variable that's in the common one there. I think it would be preferable to not do that, which does mean here where I already fixed those change. So that's good. We're down to under 30 errors now. So continuing to make progress. Now the footstep audio, that should have the movement input. So we change a few of these so that they've actually got the movement input being passed in. Just because we're not modifying that parent one, so we do want to, well, that core stored data, so we do want to be a little bit cautious with which ones we mess with. So now we've got our jump input, and with the jump input, that is one where, with how we were working with it, we were intentionally setting it to false immediately afterwards, because we're essentially processing it and then discarding it. So although the movement input, I want to preserve the original one, because jump, we are actually consuming it, I'm going to modify the original one there. And then we've got a couple of other ones here. So update running, well, that needs to get the movement input because we have potentially modified that. So movement input. We have our run toggle, and crouching again. So crouching is again one where we are consuming it. So I will actually modify that input. So that looks pretty good. So then we've got a bunch of ones where we're accessing the current surface. So current surface, I'm going to put that coming from the state as well, because I think that makes sense for the state to keep track of the current surface. So we'll take this, move it up to here. We get rid of the various accesses, and we will have things that we need to fix in our main one. But this will clear out a bunch more errors. We'll be down to almost all of the errors resolved. So that's good. We're down to 15 errors, which is very, very few. So we're getting it down to really sort of the last set of ones where it's doing some very specific stuff that we potentially need to look at how we want to address that. So update running, that needs to get our movement input, which we actually have, that just uses the raw movement. So I will actually go back to this and just have it use state.input move, because that is using the raw value there from the player. Current source. So that's good. We're almost under 10 in terms of the number of errors left to resolve, which is great. So now we've got a bunch of these events, and these events are something that I think a lot of those events, those should actually move as well. So if they're things that are very specific to a movement mode, the type of audio we provide for them. So if you're flying, the audio for when you hit the ground makes sense for that being different to if you're walking or swimming. So I think having there be different events for that actually makes sense. So I'm going to take that block of events and move these over to here. And this will actually be the first set of events we have even serialized. So we need to bring in using Unity engine.events. So now we are down to under 10 errors. We've got some debug stuff for movement. So those would actually be really handy to, again, that movement input, need to decide on where that debug actually should happen. So what we could do is we could actually have this work at the character motor level. So we could move those over to the character motor, would be an option. But we do have a need for the movement and looking locked being stuff that's accessible. So I'm going to actually, again, take those ones for locking the movement and all. And those actually make sense for going into the state. So we're going to keep them like that. Now that will kick off some errors here, which is fine. They're pretty straightforward ones for us to fix up. And again, as I said, when we're working with these, as we make changes that introduce more errors, we want to go and fix those errors. So we can close out those. So that's good. We're down to 6 errors now. Now we do have a bit of logic that's happening here before it then goes and does the updating of the movement. So this would be something where what I could do is this could go over to our character motor, and we know the movement stuff is going to happen in fixed update. So at this point here, I could change state, input move, and I could be checking if state is movement locked, like that. So that means that's going to be applied for any of the ones. And I would then actually, we've kind of gone back and forth with this a couple of times, and this tends to happen as you're working with these things. There will be bits that you adjust. So, okay, that's good. We're down to very few errors. So there's now stuff that's in the player character motor. So that's fine. Player character motor, we change stuff in state, and this is something as well, as soon as we go and open the things up, we then end up with a lot more errors that we hadn't already sort of sorted. That tends to be what happens. You go in and it then, might have one error in the file, but you actually go and open it, it processes it, and then you have a lot more errors in the file. Tends to be how fixing things goes, that you fix one error and then many more appear. So movement mode. Now input handling will have a lot of ones. The player character motor was always going to be the one that had the most errors, because it is doing the most stuff with state and things like of that. So we clear up all of its errors. So player character motor is now happy. We might as well go over and fix up the AI one while we're at it. It should have a lot less in the way of errors because it's accessing far fewer of the variables. So it doesn't have as many things that we need to fix. Mostly it's going to be stuff that we just change it to access the information from a different spot. That's really the main thing that changes with this. So that's good. And we're down to, it just says reckons there's one error and one error only, which is pretty good. If we're actually at the point with there just being one error, that's great. So I want the consuming of stamina to happen on the motor. And the motor already has functions for that. It's just not visible. Stamina we could move into the state as well and move consuming of that into the state. I don't think strictly necessary in this case. But now, those seem to have no errors. So with that set up, we should be pretty much right to go and test this. So we go back to Unity, select the player, and we'll notice we go to the player character motor. We can't go and actually change that movement mode. It doesn't appear there. And that's because this is an interface. This is one of the restrictions with interfaces, that by default they're not going to be able to be serialized. Now we can use a thing called serialized reference that would allow us to serialize a link to one. However, serialized reference has a couple of restrictions which are a little bit problematic in this case. One of the big ones being you can't use serialized reference if it is something that is based off of mono behavior. So that means that we would not currently be able to select this in the inspector, which is not ideal. Now, there are custom editor things we could do to make this work, but want to avoid this ballooning out to be going for far too long. So we need a workaround that's viable for this. So what I would do is this would be something where, for now, I'm going to change this so that it's not exposed like that. Bring it down here, and instead, in awake, I'm going to say, okay, well, movement mode, get component, and I want to get a component that implements iMovement mode. And then I would check here and say, okay, well, if movement mode is equal to null, then throw a new system, I think a null reference exception. And there's no movement mode attached. Well, we could actually call this no iMovement mode attached to, and then we just provide the game object's name. So that looks good. So it should mean it's able to retrieve it. So with luck, we can run this and it should just work. So we are getting some null reference exceptions, which is fine. What we would do is go and see where those are happening. So those are happening in the state, and that's because really, really easy to miss thing. State is a new state or new motor state. That's fine, we fixed that. And we just really want to make sure, does everything work the way that it did before? So getting no errors. I can walk, I can jump, I can crouch. The surface effects work. So everything is working as it did before, which is great. So I'm going to go and our prefab. We'll actually update the prefab based upon this. So this one, they don't have gravity, so actually I won't update the prefab to force it on for this one. What I'll do is the prefab itself, I will add in the movement mode for the ground. So, okay, that's good. Part of the whole point of this was I wanted it to be really easy to then make it so that this character could fly. That was the goal. So what I'm going to do is I am going to get rid of this. I'm going to bring in movement mode flying. Now I can get rid of that one. Movement mode ground there, I'm going to also remove. So because I added it onto the prefab, it adds it onto everything. So flying, well, I can go and say, okay, you implement that movement mode. Now that's going to immediately throw up a whole bunch of errors, which is to be expected. That's okay. Because what we're going to do is implement the bits we then need for the flying. So I'm going to bring all of these across because we have to bring all of these across. All of these become public. Now, there'll actually be very little that we need to implement for this, which is great. But I just need to get these different functions set up so that we are right to go and we don't have heaps of errors that are sort of unrelated. Got that. Now it is going to have a couple of things that are in common, so the state, stuff like that, I'm going to make sure those are being stored, because that will be really useful to have. And our current height, things like that, those we will bring across those functions too, but I firstly, for now, just want to bring over the config stuff. So that's being set. Now I'll bring over our hide and crouch ones, because those will actually change. And this is why we wanted those in the interface, so that the different movement modes have to actually override them. Because our height's never actually going to change when we're flying. So we just always return config height. Our max speed, well, other things really shouldn't affect it. We're not worried too much about sort of surface effects and that. But what I will do is decide that, okay, I could use run speed. I could have a separate speed that I use for this as well. But I'm just going to go with using the run speed. So that's pretty good. Grounded, I don't actually want grounded to be a thing. So I'm just going to return a new raycast hit. So just going to have an empty one of those that it returns. So, okay, that looks good. These flying ones disappear. So, okay, not too much then else that we actually need to do. Now we did have in our movement mode for grounded, we did have a couple of things here. Gravity, I actually don't want to bring across. I don't want gravity to apply. I will bring the alignment across. I think the alignment is a useful thing to have. So we have our alignment one across. Now, the actual rest of the stuff, most of it's going to be in our fixed update for where it's doing the movement, which we can go and see, okay, is there anything from the other one? And there's not really. Most of it sits in this update movement. So with the update movement, time and air aren't going to be applicable. A lot of the stuff, so jumping, things like that, won't be applicable. We will need to set up something where it's adjusting the velocity, so that's okay. So really, we can just directly go to calculating the movement input. So what I want to do is I want jump and crouch to control the vertical. So I'm going to say the vertical input is equal to, so if state input jump, then I want that to be 1, otherwise 0, plus state input crouch, and that will give us a -1 or 0. The idea being, if you are pressing just jump, we go up. If we're pressing crouch, we go down. If you're pressing both, you stay at level. So that's ideal. So we can calculate our movement input, which, okay, we want to move kind of in the direction that we're looking. So we're going to go camera main, transform forward, multiplied by our movement input, and we would be using the Y component of the movement input. Then, similar thing for moving side to side. So that would be camera main transform dot right. And again, that uses the X component. And then we have vertical. Now vertical should be relative not to where we're looking, but to the gravity in the area. So that's where what I would do is I would use state up vector multiplied by the vertical input. So we've got our movement input. So then I would just set our velocity, so the state linked rigid body velocity is equal to our movement input multiplied by our current max speed. That should be enough to make us fly. Let's test. So we've got set up here, it's got the movement mode flying. So if we run this, we should be able to fly around. So I can still look, I can fly. Now if I press jump, I keep going. And that's because of how the input there currently for jump works. So I'm going to go to our first person controller, and we'll notice for things like run, we get press and release. So for jump, we want to get both press and release, and we already have that for crouch. So we can save that. And then now what I should be able to do is fly around. I can use jump to move up. I can descend. So we've got our ability to fly. And then with this, all I need to do, if I want to make it that they're not flying, I can remove fly component. I can bring that back for the movement. And then testing this, I should just be able to move around exactly as I could before. And we want to just double check that we didn't break anything with gravity or stuff like that. So with our scenes, I'm going to make sure this is saved. We go to our inverted gravity. Just check that the player looks like they're configured correctly, which they are. So we'll just double check that that allows them to move around, which it does. So we've got that working correctly. Want to make sure that the AI is also happy. So the AI would need the movement mode for the ground as well. And we'll update their prefab too. So then we want to make sure that the AI is moving around, and we can see that it is. So we've now got our character motor set up where we can have it work with different movement modes, and we've got that core set of functions that we need. And as we found, it was very, very easy once we had that set up to add in something like flying. So it took a lot of time to refactor it. It was a lengthy process there. There's a lot of things we needed to move. But once we had that moved, and that new architecture for it, very quick and easy for us to add in movement modes. Now, there's going to be further things we want to do, like adding in some improvements with the inspector so that we can easily just work with the different movement modes there. And we also want to do some changes where we go and set up other movement modes, because now supporting things like swimming and ladders and stuff like that are a lot easier. We can have the character go to a ladder, and then we switch movement modes when they go to use it. And then that changes how all of the input gets interpreted. So it's going to give us a lot more flexibility going forward with how the character actually moves, which is going to be fantastic. So dive on in and experiment with it, see if there's other movement modes you might want to add in, and the cool sort of things you want to try out there with it. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you've got any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. You can freely use that code in any of your own projects, commercial and non-commercial ones, you're able to be using it. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below as well. But until next time, bye.